Hi, welcome to the BVS Studio channel. Today, we're talking about link extension methods. Many people dot on them, but today, you'll know how link extension methods slow down C# apps and why sometimes it's better not to use such extension methods. A while ago, we started improving our analyzer, although we never stop improving it. But anyway, once, while tracing the C# analyzer core, we found that garbage collection took too long. So we dug into this issue and realized that the link was to blame. Link objects messed up the heap. Besides, objects had shorter lifetimes, so garbage collectors always had much to clear. What is wrong with you, Link? What's exactly the problem? Where do all these objects come from? Let's figure it out. Suppose the method receives a set of numbers as an input, selects positive ones, and displays squared positives in the console window. So how many objects will have in the heap? Let's see what happens when this code executes. We're lucky the link source code is open source. By the way, if you want to solve this issue yourself, check out the description to find the link to the folder in the official repository. So we have IEnumerable. We call the where method for it. The where method returns IEnumerable. In fact, the where method returns an object that inherits iterator, the internal link class. Call of select also creates an iterator object. Programmers often use descendants of iterator and link. Their main feature is that they implement both IEnumerable and IEnumerator interfaces. With this feature, we can use the same object both for the enumeration and for its enumerator. However, such an approach is handy only when we get the enumerator once. If we get it again, new iterator will be created. Generally, link methods create iterators. Their specific classes depend on the object's type for which we call the extension method. For example, if we call the print5 squared positives method for list, then where creates the where list iterator object. The following select method creates where select list iterator. In the for each loop, where select list iterator calls get enumerator without creating a new object, because such a call returns the iterator itself. However, even such a simple query creates two objects in the heap. Every time we call the extension method, the number of objects in the heap increases. So what if we solve the issue without link? IEnumerable in for each without link requires memory allocation for one object, enumerator. It goes to the heap when we call getEnumerator. You've probably noticed the absence of lambda expression here. They also create additional objects in the heap. You've probably noticed the absence of lambda expression here. They also create additional objects in the heap. Lambda expressions slow down the app if an expression uses captured variables. But we'll get back to captured variables some other time. In fact, it would be better if the method got list instead of IEnumerable as an input. In this case, there will be no new objects in the heap. After all, if we call getEnumerator from list reference or some other standard collections, the enumerator is created on the stack. However, even if we have an IEnumerable reference, it's better to create a single object than to create an iterator for each link method. It will also help to eliminate the possible overhead from lambda expressions. Of course, there's nothing wrong with some additional objects if the code executes rarely. These objects almost don't affect the program's runtime. However, if the code runs hundreds of thousands or even millions of times, the difference becomes noticeable. That's exactly what we had when we were improving the analyzer. If your code snippet calls several link methods and executes very often, it's better not to use link methods, at least in this snippet. By the way, we have an in-depth article about this improvement. Check out the description to find the link. That's all for today. Feel free to comment and see you soon.